another area where that kind of a thing would be useful if you're doing, you're a photographer or something and you're taking aerial pictures with drones. You like to coordinate between, so you have some, and they embed some algorithms about their spacing with respect to each other, and then you're trying to control the centroid or something, or yeah, something like that would be.
Somebody tried to do that with some.
Yeah, no, I'm not.
Remember that blades group?
That's a different.
Yeah, I'm not suggesting you implement something like
Yeah.
that. I'm just talking about the model behind what you're,
So can we do a hardware project?
Yeah, as long as it has an element of software to it.
So do we have to apply like most of the technology like you listed on the website, or we can?
That's the question again?
So you listed like a stack of technologies that we can use.
Yeah.
Right.
You don't have to use them all. They were just there as thought provokers, that's all.
Oh, okay.
No, I want you to use some more than just ho-hum, very plain Jane technology that's been around for the last 30 years. I want more than that, but, there's no obligation to have 3 of those technology or something.
Well, what's the scale that we expect from the system?
So the concept ought to be reasonably big, as I was talking about with Christina, but your implementation could be one little tiny slice of that. So one Raspberry Pi talking to your laptop, as the aggregator, and your phone talking to the service that the laptop is providing, or something like that. That's fine.
So the OCD has to be pretty broad.
The concept has to be, wants to be, you want to look at it and say, yeah, this could be a part of that system. Isn't that cool? That's what you're trying to trigger. When you stand up, I'm getting ahead of myself. Well, I'm not getting ahead of myself. So, I would like project write-ups from every one of you. I told you by the end of this week. Anybody that hasn't emailed me a project by, I'm going to look at my email first thing Sunday morning. And if I don't have an email from you, I will assign you a project. Okay? And I will be working alone. So you really want to send me a project description. It's okay if it evolves some over time. But what you want to do is, I don't want just totally hand-waving, so vague that it could be anything descriptions. Okay? I really want to see a reasonable amount of reasonably specific things, but no harm at all if, as you think about it a little bit, your concept moves a bit. That's fine. When you get up for the first technology presentation, I expect a pretty solid description of your project. Here's what I want to do. Not in vague terms, in quite specific terms. So here's the big picture, and then I want to do this task, and 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 when I'm done, here's what I'll have. So, I don't always get that on that first presentation, but I'm unhappy if I don't get that. I want it to be specific. I don't want hand waving. But again, even if you get up on your, in your first presentation and you lay out a fairly specific project, and then as you get into doing the probes, you get interested in moving it a little bit, or you find that there's some roadblock that's, really you need to work around. It's fine to make some changes like that to evolve the project as you go. So I want a project description from every one of you. And you have a list. You don't have to stick to the list. It's okay to propose your own project. What that means is that we will have some negotiation to do. If you propose a project that isn't on the list and doesn't sound anything like any of the projects on the list, that's okay. You can do that. But then, there may be some negotiation between, I'll look at it, and if I think it's not enough, or it's too much, or it's too hard, or it's too easy, in any of those cases, we'll do some negotiation. But what I will do as soon as I get your project description. So in that description, you know, describe the concept for your project, and my mental model is about a page, maybe 3 paragraphs. It's okay if it's more, probably not okay if it's less. And you want to be fairly explicit about what it is you're really trying to do. And then what I will do is then I will schedule out the presentations. And so an important part of that is you telling me if you're planning on working with somebody else, who you're going to work with. Because if you're working with somebody else, the 2 of you will present together. It'll take a little longer. I expect if you work together, you're going to do more than somebody working alone. I left the presentations from last year on the website. So you can find them and look at them. So if you're going to do something that somebody else did last semester, that's okay. It's okay to look at it. Just don't hand me their material as yours. That's absolutely forbidden. Okay. But you know, if you want to look at it and get some ideas and say, oh, that's cool. You know, that's fine. Any questions? Before we proceed, so how many people have a pretty good idea of what they're going to do? Raise your hand if you have a pretty good idea of what you want to do. So I'm worried about you guys. I'm now worried, okay? I didn't see very many hands go up. This Sunday. So today is Thursday, Friday, Saturday. That next morning, I'm going to look at my mail for project descriptions. And I told you that last week that I wanted your descriptions in by the end of this week. You were warned. I will. It's what I talk about today is kind of open-ended, and I don't mind stopping a little short. Maybe I will do that so that you can ask questions, you know, about what's plausible. So maybe while I'm talking, you can, with half an eye, you can go back and scan over that list, you know, and half listen and half scan the list and think about it a little bit, and then, you know, you're welcome to ask questions. Whatever you want to do. But I need a forcing function to get you guys over the, over that. Are you? Right?
Yeah.
So you're one of the people that didn't raise his hand. I'm surprised. Okay.
Because I'm not pretty sure about my idea of the project.
It's okay to, if you have an idea that's interesting, but you're not sure that you can implement it, that's okay.
I mean, interested about the specific technology listed on the website,
Yeah.
but I'm not sure if I can, group to implement this amazing application based on the technology.
Yeah, so you need to wrap that technology around something tangible that you
Yeah.
want to do. One possibility is, we've done lots of distributed collaboration system type things. So if you're interested in Node, you could do, mock test harness and mock repository and stuff, all that implemented with Node. And, take it, maybe you could collaborate with somebody who was interested in building one of those things. That would be okay. I would rather see you reach high and not quite make it than for you to reach low. Okay, because there is no great penalty in this course for not doing everything you promised, everything you said you would do. Okay, as long as what you're trying to do is reasonably challenging, I don't No, this is intended to be an exploration for you in these technologies. So, and not every exploration gets exactly where you had expected to get, and that's okay. As long as you do, reasonable things. And we're interested, you get up and talk and you tell us what, and we're interested. Okay. All righty. So what I'm going to do today, so my game plan is this. I'm going to lay out a roadmap getting us to COM, talking about component models. I'm not going to talk about COM much today itself, other than in very broad terms. But, and then on Tuesday, I am going to do some demoing of VS Code on Linux, doing some system programming on Linux and compare it with, what's in Windows. So that's what I normally would have done that today, but I'm not quite ready with VS Code yet to do that. And then after that, we're going to be hardcore COM. We're going to be walking down that COM road, yellow brick path. Okay, so I want to look at these two things. These highlighted things are things I want to look at. So this Windows component demo is very like the DLL, not exactly, a little bit different, like the DLL thing, but I want to compare it to this Linux. Okay, I'm not going to run the Linux one because I don't have my VS Code up and running, but we'll look at the code and see, how it differs. And then I'm going to walk you through a reference counting demo. I think you're so what you're going to do in Project One is you're going to build for Windows a COM component that COM does reference counting. COM, does allow you to switch between interfaces and all that sort of stuff. I demonstrated the interface switching last time. And so you're going to build a component that works a lot like COM. It's not COM, but it works a lot like COM on Linux. So you want to know how to, one good way to do the reference counting stuff. And so we'll look at that. So let's pull up this Windows component is in Project One Help Spring 18 component demo. So let's go there. Project One Help Spring 18. Component demo Windows.
Sir?
Yeah.
It seems the link is broken for us. The link is not responding for us. It's a 404 error.
I'm sorry.
The link for this thing, the Windows demo, we are not able to access it.
Oh, okay. That means I have probably moved something. Hang on a minute. Let me pull up Google and just go to, call it server. Oh, yeah, I got to open I got it connected. Okay. So this is, yeah, okay. Apparently I forgot to upload it, so send me an email and I'll upload it. If you remind me at the end of class, I will upload it before I leave today. Okay? So you can just look on while I pull it up. So here's the component. I have an iTest interface and so it has the, decal spec. You will have to, on Windows, when you build your DLLs, you'll have to do this kind of decoration, okay? Because Windows DLLs, if you don't put those exports on, nothing is published. None of that information goes to the link map, and so the loader can't find it. So you have to use those imports and exports. We talked through that. If that confuses you, we can talk a little bit more about it. But so this is just a little tiny, So here, typically, so here's a interface, a C++ version of an interface. We'll always have a virtual destructor implemented with an empty body. It has no data, nothing to return. The reason it's there is to put a slot in the virtual function pointer table for destructors. So that guarantees that slot is there. So even if the derived class forgets to put virtual for their destructors, it'll still be virtual. Because once it's virtual, it stays virtual. And the destructor of the class, if you inherit, it'll make your, it's whether you put that, you should put that decorator on, but whether you put it on or not, it'll be a virtual destructor. So, and then a static create test that returns a pointer typed as the interface, but it's actually bound to, to some concrete thing. It has to be bound to some concrete thing, or you couldn't use it. But it's typed as if it's, pointing to this interface. And I have a virtual function bool test, which is pure virtual. So that means that this is abstract. You can't create an instance of it. Okay. This means it's abstract. This means I can create an instance of it. Now notice, I can't implement this until I've seen the class that's going to implement that interface. So this create test has to come below the class that's going to implement the interface, so that, because I got to call new on it. That factory has to call new, so the factory has to see whatever it's going to create. But your clients don't. That's the important thing. The developer of this library does, but the clients don't. And here's an external, global create test with extern C. And so if I'm going to do a explicit load, I need to use that global test. Same kind of stuff we saw before. Here's our component. So here I'm deriving from public test, and notice that I have a virtual destructor, but this would be virtual even if I left this off, just by the fact that I've inherited from my test. Okay. And the constructor in this little demo doesn't do anything, okay? So for test driver, and the destructor doesn't do anything because it's just a little tiny demo, but it's there, just to say here's where you put stuff. Here's the create test. Return new test driver, and notice that I've already declared this class here so it can do that. Notice that this create test is not a test driver method. This is an iTest method, okay? But it has to be defined below the class definition so that it knows how to call new. With me? Does that make sense, Arpit? And then the global create just returns new test driver. So this is a a static member of the interface. You can't do that in C# and Java. They don't allow statics in interfaces. You can make an abstract class. You can do the same thing I've done here. You can't use the keyword interface in Java or C# because they won't let you put any static methods in. I don't know, but you can make an abstract class that works the same way. Does the same kind of thing. You can do it the same way. But anyway, and then my test function, I just automatically return false because I haven't implemented anything. So whatever you do, whatever you test. And what I'm going to do here is use on Tuesday, using VS Code, I'm going to step through my file system, and I've got a sequence of tests. I've got a little test harness. The same idea as this. I'm not actually loading DLLs, but it's a very similar idea. We'll see how that works. So that's a component. It's really a virtually empty component, but it's just showing you the mechanics of doing stuff. So here's the client. Notice that I am linking in this client that wants to do an implicit load, so he's linking to the library. This lib file does not have the code from the library. All it has are the fix-ups, the import, export fix-ups. That's all that's in that lib file. It's a little tiny lib file. Almost nothing in it. So just so that the loader can resolve those references that the compiler couldn't because it was just compiling each CPP, one CPP at a time. And then the implicit so this is implicit load component. So this is my client. I called it implicit load component. And so here I am simply using the static method create test. Okay, because it's being implicitly loaded, I don't have to worry about name mangling. That's just a question of resolving those fix-ups. When I explicitly load, I have to resolve the fix-ups. So unmangling those names are important if I'm going to explicitly load, but implicit loading, it doesn't matter. Because the compiler is perfectly happy with all those weird symbols, and the linker is perfectly happy, and that's all that's required, that they can talk to each other. That's all that's required. So I could use this ITest right out of the interface, and away we go, and it'll return false, because that's what my test returns.
Sir?
Yeah.
So in that case, why do we have to ever use explicit loading then?
COM uses explicit loading. So here's the deal. I may have code that, depending on what I'm asking it to do, uses a lot of stuff out of libraries, big hunks of code out of libraries. If I don't ever use that functionality, why would I load it? I want to keep my footprint as small as I can, so I do as few page faults as I can. If I let my in-memory footprint get too big, I've got to start page faulting like crazy, and my performance is just going to go in the dumper. So it's a performance issue, but it also could be, I may want to specify for this guy, it's in these certain paths over here, and this, so there could be a bunch of logic about where I go and grab stuff, like a typical plug-in kind of thing might do that.
Oh, so in both the cases, the entire DLL will be loaded, right? Even if it's
Yep. The only difference is that with implicit loading, as soon as I make a reference to anything defined in the DLL, it's automatically loaded by the loader because it has that lib file to resolve the references. If I explicitly load, I have to resolve the references, okay? And so I don't link to that lib file because I don't want it automatically loaded, okay? So if I don't link to that lib file, it means I'm responsible for doing the fix-ups. And so, we'll look at that explicit again. So here's the explicit. Pardon me, my son is still in the hospital, so let me It's just spam. I can't silence it because my son's still on the hospital line. I want to make sure if something happens, I know about it. So here's the explicit load component. So now here I am explicitly loading the library. So what happens is for the implicit loading, that library has to be in a search path that the loader will find, and that typically means it's in the same directory as the application that's loading it. So wherever that exe is, if I put the DLLs, guaranteed the loader will find it. But there's other paths that it checks, and there's ways of modifying that. So I'm loading the library. Now I could mention some totally different path here. You know, I happen to be pulling it right out of the same directory where the exe is, and as long as that succeeds, I go. Now notice that this is a status. COM and the Windows API uses those status methods rather than throwing exceptions. The reason COM does is if I have compiled some of my code with G++ and some of my code with Visual Studio, no guarantee that Visual Studio can catch an exception thrown by GCC, because there's no binary standard for C++. So there, as long as they satisfy the language standard, they can implement it any way they want. There's absolutely no guarantee. And one of the goals of COM was that I can run libraries that are compiled on different compilers. So COM doesn't let you, what COM says is any exception thrown in this component has to be caught in the component and not allowed to propagate because it may not be catchable in the client. And you take that, you catch that exception, you turn it into an error status and return the error status. And that's the way the Windows API works. It typically uses these error codes. Partly because it's implemented in COM, and partly because that part that isn't implemented in COM was implemented long enough ago that that's the way we all did it in the bad old days when we didn't have exceptions. Okay, so we return a handle, and as long as I get a success code out of that, then I proceed. Now I say using GC create ITest. So where did I define GC create? So somewhere, oh, I did it right here. So GC create equals ITest star. So this is a function pointer pointing to a function that takes no arguments and returns a pointer to an ITest, typed as an ITest object. Okay, and that's exactly what our creational functions do. And so now I say GC create get proc address. So here's where I do the fix up. I'm getting the address of that function, you know, that matches this. So I'm naming that function. So if again I get a status code out of get proc address, and I have to cast it to this type because get proc address is going to give you addresses of all kinds of functions with all kinds of different signatures. It doesn't know what. It's typed as a void star. So the compiler will accept anything. And now, in order to bind it to this function pointer declaration, I have to cast it. That's what I'm doing there.
So, Professor, the return type of get proc address, so it won't be a raw address or something? I thought it might be an X.
So what it is, what you're getting there, it's a real address, but it's an address to that table, to that code. Really what you're getting. You're getting a pointer to that code. So when you call a function, you're building up the stack frame parameters, and then you're jumping to that code. Okay, you're putting into the instruction counter the address of where that code starts. And that's what you're getting out of. You're getting that address out of. You know, there's some jiggery-pokery details that have to do with how the object files are laid out. You know, there's different regions. You know, it's a little more complicated than I said, but you know, that model is a perfectly reasonable model to have. And I'm quite sure that this address physically is the address of the code. Okay, and now, since what I've gotten is a pointer to that creational function, now I have to use it. So if this succeeds, I now use it. And what this has done is created an instance of the class that implements that ITest interface. In this case, there's only one, because I'm not using a parameter on the create function, so there can only be one that implements that interface. If I had a parameter, it could be multiple ones. But in any case, I'm binding this, even though it's typed as an ITest, I'm binding to a concrete object, okay, my component object, and then I execute the test and either say it passed or failed, and away we go. So that's that whole example. And nice small, yes.
We are calling this static function using that handle, right?
So here I am calling, here I am calling the global function, not the static function. There was a static function that my implicit load client called. He's calling the one in the static function in the interface. Okay, but that's a mangled name. But he can make that call because the loader and the compiler are resolving all those references. But because I want to load this on demand when I want to, I can't link to that library that resolves the references. I have to resolve the references, and that's what I'm doing here. That's what get proc address does.
So if we know the name of that function, that mangle name, can we call those?
You could, but you don't want to. How the compiler mangles name changes with almost every version of the compiler. I've looked at it and I found that indeed it does. And you'll never remember it. You'll never get it right. It'll be a bear to maintain that code. So there's a little program. If you want to see what it looks like, there's a little program called dumpbin. If you run dumpbin on the DLL, it'll show you what the exports are, and you'll see the mangled names. And you'll see for that global function, it's unmangled.
Can we call the private function using this module or not? Can we call the private function using these modules, this a handle or not?
This has to be a public function. I think it would fail to compile if it wasn't, but this is just a creational function. This has nothing to do with the component itself. This is the factory that's generating, that's giving me a pointer to the function. And now with that pointer, I can call any public function. Does that make sense?
Yeah, because in Java, it's the same way we can do this type of things in Java and in the reflection. We can call public and private.
Well, you can do in Java and C#. You can do that with reflection, but C++ doesn't have reflection. And you're not really doing the same thing. You've already loaded the library, and now you're interrogating. You're calling activator get create instance and unwrap. Okay, and you're really not. You're not really. No, you are demand loading it. I take that back. You are demand loading it. So, reflection is going to give you unmangled names. I don't know whether C# and Java mangle names to handle overloads. I'll bet they do, because that's by far the simplest way to do it. So I bet they aren't mangled, but what's in the reflection is unmangled. So whatever you get, you get the functions, from reflection. They'll all be unmangled. And you could yeah.
The same place where the getProc address is called, the parameter, the first one, it has the status, right?
So this is the library that I loaded. Okay, so it could be in a bad, this is a handle, but it turns out that if it fails, the handle is given a particular value. See, understand that a handle is either a pointer into or an index into an address table in Windows. So it's just a long int. That's all it is. But it has some values, some status values that won't be addresses in that table. Guaranteed they won't be. Typically negative numbers or 0. So that's why I can use that both as an index to get my hands on that object, and I can use it as a status. It's just a pointer or an index into that address table. It isn't really pointing directly at the object. It's indexing me into the address table, and the address, what I get at the end of that index is a pointer to the real object. And Windows does that because it's constantly moving those objects around. Because of we're using a page virtual memory system, those pages are coming in and going out of memory, and so the next time I call it, maybe in a totally different address, totally different address. But my handle doesn't change. The address table changes. The address in the address table changes. Okay, so let's take a peek at, I don't have a Visual Studio project to load this. So here, component demo Linux. I think I have a NetBeans project, but don't know whether I do or not. But here's the component. Oh yeah, it's a NetBeans, so I have a NetBeans project. But probably with this current version of NetBeans, I've discovered that every time you update to a new version of NetBeans, the old projects don't work and they don't transport and they don't convert, okay? You got to rebuild the project, so my guess is that that's what would happen. But my goal here is just to look a little bit at the code. So here is the component. So now, it's identical except no imports or exports. Because I believe, I'm not an expert on the way Linux does its job, but I believe that DLLs by default export everything. And so, so you don't need that to tell it what you're going to export and what you're going to import. We'll look a little, if we have time, we may not have time today, but if we have time, we'll look a little bit at how you build those DLLs, what's required. Now let's take a look at the, I want to go to the explicit client. So the implicit client is kind of like our implicit client. There isn't that much difference, but let's look at the explicit client. And here's how Linux does its stuff. Well, first of all, I have different headers that I got to include. So this one is the one you have to include to manage DLLs. They call them shared libraries. That's really what a DLL is, shared. Now, here's this is just like load library. This is doing the same thing as load library. It says DL open libcomponent.so, and this is saying I want to do a lazy load. This is just an enumeration. It's going to do a lazy load. And I get back a handle, and I test the handle. So it's very like the Windows. It's just that the functions you call and the headers you include are different. That isn't universally true. Some things you do when you do system programming on Linux are quite different than what you do. But in this case, it's virtually, it's one for one. It's just different function names. And so, and here, I have a comment that when you've built the library, you want to copy it into UserLib. And that's how, because that's where the GCC or Clang, whatever you're using, that's where it looks. So, and so now I want to call the equivalent of get proc address. So, so I have a perfectly valid using declaration in, this is as of the aliases. This is an alias. They were as of C++11. And I was compiling it with C++11. But at the time I compiled it, this wouldn't compile because of a quirk in G++. I think by now it probably would compile. But you can do the same thing with a type def. So here's the way you define that with a type def itest. And now you, instead of gc create equals, now you just put gc create in here. That's the old type def way. A little more confusing to read. This is easier to understand, but, and now I'm just going to call, now instead of get proc address, it's dlsim. Give it the handle. That's exactly what we did in Windows. Gave it a handle. And this is the function we're trying to call. The name of it, just like we did on Windows. Same. Okay. And if it doesn't create, then we print out that it will fail. And if it does, we use it. So very similar. Now you will have to build shared libraries on Linux for Project One. Because in Project One, our job is to build two components and a client. A component that finds the file paths, returns the files that it found for you to analyze, and then a component that does the analysis file by file. So you'll need to create these libraries, and so if you're going to command load it, and I would like you to, because this is really what COM does. This is the COM way of doing things. It does a demand load, in large part so that you minimize the amount of stuff hanging around in memory. Okay, so you don't load these libraries unless you need them. And I believe if that library happens already to be in memory, I'm quite sure that both Linux and Windows won't actually load it into memory again. What it does is there's a table of those objects in memory. It looks in the table, and if it's there already, it just bumps the reference count. The reference counting is important. Bumps the reference count. Okay, so very like the Windows, it's just different headers, different function names, but the ideas are identical. Okay, I'm not going to pull up the implicit because it's, same. Now let's take a look at this reference counting demo. So that is in Project One Help Spring 18, and you probably won't. Is that link good? Try it. Yes? Good. Okay. So I have at least one thing right. So let's. Why would you take me back to where I was? I think this is, that Project One Help is 687, so let's go to 775. Project One Help Spring 18. And reference counting demo in Windows. I have two reference counting demos. This is the right one. Yep. We'll find out when I load it up, but I'm pretty sure it is. What happened? All right, what happened? 1 second, this is 687, damn it. 87, 775. Code. Oh. '18. Reference counting component. Let me just drill down into this. Did I mess up? Let me load it. It has exactly the same structure as the Windows demo. Let me see what's cooking here. I thought I had done something quite different. So let's look at the component. Oh, no, this is the right one. This is the right one. Good. So now, here's the component. So notice I have an iLifetime.h and iTest.h. Let's look at iLifetime.h. So iLifetime.h, I wanted the, yeah, here it is. iLifetime.h has two virtual functions, add ref and release in a virtual destructor. Add ref and release. And that's exactly what our COM components is. I named this like COM because I'm trying to gently move toward COM. So, and what happens is in COM, and I think that's the way I did it here, any function that returns, like a factory that returns a pointer to an existing object, is obligated to increment its reference count. So the client only calls release when he's done with it. So, with luck, that's the way I did it. So, so here's iLifetime. Now, here's my lifetime base. And so, I'm enunciating that in the destructor that I'm destroying, so I'm destroying the instance. But here, so add ref does ++ ref count, return ref count.load. So what's happening is my reference count is an atomic because there may be, remember this is a shared library, so there may be multiple processes that are talking to it, and you got to do the same thing with COM. Okay, COM works the same way. And so I have an atomic here, and the atomics, this is an atomic operation with the atomics, incrementing and decrementing. That's what the documentation on the C++ atomic library says, so I'll take them at their word. But to load them and store them, you got to explicitly call load and store. So this is atomic, and you know, it may well have a lock, but it's probably unlocked, just an atomic operation. And so anyway, so now when you call add ref, you just increment the reference count, and you're returning that reference count just in case somebody, normally nobody looks at it, but just in case you want to know how many other objects are currently talking to this beside me, you'll know. Here's what relief does. It decrements the reference count. If the reference count.load is equal to 0, delete this. Harry Carey, commit suicide. And then return reference count.load. Okay. So, and COM kind of works that way. COM has often a separate library. Well, you gotta be careful. A lot of COM, most of COM these days are built with a library called ATL, Active Template Library. And it was designed to help you build ActiveX objects, and ActiveX objects don't really exist much anymore. Nobody uses them anymore. Well, they are under the covers. Some of the WPF objects are really ActiveX objects. But, and the Active Template Library uses a structure just like this. I'll show you when we start talking about COM seriously. I'll give you show you the structure of the stuff that is built with the Active Template Library. But anyway, so this is a component, and now in my, this is the iLifetime, and now in the component, so here's my class. Remember that iTest derives from lifetime, and my component derives from iTest, so I derive from both, okay? Transitively. So that means that on my object, you can call add, ref, and release. And so, and now the rest is absolutely identical, you know, where I'm only doing trivial things here. But now let's look at the client. So here's the implicit client. And so here, he creates this instance, and that should have incremented the reference count. Let's go back and look at it and make sure I really do that. And then, you know, I use it, and now, apparently I didn't, because I'm doing an add ref here, okay? So, oh, no. So this create function should have incremented the reference count. What happens here is, I'm just illustrating, if I make another pointer pointing to the same object, then it's my obligation to call add ref. Normally we wouldn't do that. But, and now, so what I'm doing is I'm creating a p-test2, and now I'm releasing p-test, and, you know, and away we go. So if I run this, let's set this client up as startup. So pretending to test the component, creating test driver instance, test pass, destroying test driver instance, destroying lifetime based test. So my decrement worked, and I am literally unloading that library in the code. So what happens here is when we go back down and look at that, let's look at that component one more time. So where did I do that? Where did I do that? Maybe I have my client do it, because really the component itself shouldn't unload the library. So let me take a look here. I know I did it somewhere. Here's the explicit load. Maybe that's where I did it. Yeah, here. So in the explicit load, so I explicitly loaded it, and now what happens is if my reference count goes to 0, I call free library on that. So this is a Windows function. I call free library on the handle for that library that I loaded. This is what I got when I loaded the library. And this will return true or false. It returns true if it actually did unload the library. And then I unloaded the library. Otherwise, it failed to unload the library. So, and COM does exactly that. What happens with COM is that when the reference count goes to 0, COM polls the open libraries, the open COM libraries, and it will unload COM, the COM runtime unloads them. Your class doesn't. And one of the reasons for doing that is you can tell COM, even though the reference count is 0, don't unload this library because I am in a high traffic web server and I know I'm going to have another creation of that. So, so don't unload the library. When we get to COM, I didn't do that here in this code, but when we get to COM, I'll show you.
Did you pull this code from help, like Project One Help?
Yeah, I pulled it from my Project One Help, and I think I forgot to fully upload it.
Yeah.
And Lakshmi is going to remind me at the end. And what I will do is, as soon as I walk back to my office, I'll upload it.
Sir, so we do in this way only if we have a static function, right? Because else there won't be any shared objects of the library, so we won't be needing any reference count. Only if there is static function in the class.
No, so this reference count, there's actually in COM, there's two counts. One is a reference count on the object. And so if there's several people using that object that was created, it doesn't get destroyed until that reference count goes to 0. The library is actually unloaded in COM. There's both the reference count has to be 0, and there's another count that tells COM that it's okay to unload it. If it's 0, it's okay to unload this library. And what happens is a function called lock server and unlock server, and lock server makes that count be bigger than 0. And so when your application when you're shut down, you're gonna tell COM that you're gonna unload this live. Only you're not gonna tell COM if the server is locked. You're not gonna tell COM that when the reference count goes to 0. You're not gonna tell COM. But that's the idea.
You created another pointer, right, for the same one that's already created?
I did just to show you that if I manually create another pointer, then I got to call addref for that. So when I've got a pointer to an object, and now I assign another pointer to that same object by assigning the pointer values. Okay, then now I have two references, so it's my obligation to bump the reference count. Normally we don't do that explicitly. You know, functions are the ones that manage that kind of stuff. So, you know, normally a normal COM client doesn't call addref. But, you know, if you do something weird, like, you know, like you manually aliasing another pointer to an object pointer, then it's your obligation to call addref.
Question about this ref count is equal to 0, then free the library. So we're actually unloading the component which we are loaded, right?
Yeah, so here, when I call free library, I'm trying to take that library out of memory.
What if someone is using that?
But if they're using it, see, the reference count won't be 0.
No, but that reference count is not
Oh,
atomic.
so
right?
what happens is, so I'm telling, in COM, I won't call unload library, okay? I'll tell COM that as far as I'm concerned, it can unload it. But there may be other people that are using it, so, you know, there's some bookkeeping that COM does in the COM runtime to make sure that it doesn't get unloaded if somebody else is using it. There's a component, there's a object count, which is what the reference count is. There's a component count, which is how many people are using that library, not that class, not an instance of that class, but how many people are using that library. And so when you call release, the final release on all the pointers you have, then that library reference will be decremented. But other people, you know, so it won't get unloaded. You know, all the OSs have to manage that same kind of way through a reference counting scheme. Same thing is true on Linux. You know, even though it's not COM, you don't want to unload a library out from under somebody else who's already using it. So there's this reference counting going on down in the kernel or wherever somewhere.
Sir, regarding the same question which Arpit has asked, suppose there are two different applications which are trying to load the same DLL, one after the other.
So what happens
There will be
is
only one DLL loaded into the memory, right?
one loads it, and the second and puts and its reference count gets to 1. Its module count gets to 1, and then somebody else calls a load library, and the module count goes to 2.
So even now, if we are trying to execute this particular last lines when ref count equals 0, it won't be 0,
All
right?
we're doing is killing the object. Now, I happen to be unloading the library, but that isn't what COM does. COM looks at the combination of the ref count and the module count. So the module count is bumped by each person who tries to load the library. Whether it's implicitly or explicitly, that count is. So COM won't unload the library, nor any, any other part of Windows, all the parts of Windows that do that are COM, but in Linux, same thing. They won't unload a library unless there aren't any.
What's the difference between module and rough count?
The rough count is counting the number of instances of the class inside that library that have been created. Module count is counting how many people tried to load that. And when I do my final release, then that module count, when I, basically in COM, in a most sane application, I just did this as a demo, but in most sane applications, you won't try to unload the library, you let the fabric take care of that. And the way you do it is your final release decrements the module count. We'll see that. We'll see those two counters. I'm going to show you in maybe a week or two fully formed object with the raw C++ code. It's going to be painful walking through it, but you got to do it at least once, okay? And we'll see both the module count.
Yes, sir.
Yeah.
So this is a emulation of the COM model, not the actual COM.
So this shared library stuff was created before COM was created, but not too long before, I think. I'm not totally clear on the history. So there had to be, an OS has to make sure that it isn't going to unload a library that somebody is currently using. So there has to be a mechanism, something like that. Now, in the old days, there were no classes, there were no instances, it was just C code, so the only thing they counted was the module count. But, any operating system had to manage that. I don't think that was a novel thing. I think COM just did what everybody does.
So another question is that we can do dynamic loading and unloading in C#, which is
Yeah,
other project.
yeah, that's similar.
But is the dynamic loaded library reside inside the program or the OS?
So what happens, it doesn't reside inside the program. What happens is that the library resides in memory, in another page of memory somewhere, okay, and that's managed by the OS, okay. You didn't do anything to make that happen some specific way. But it's just sitting there because multiple programs are using it. The directory services, so anytime I run Windows, I'm probably running 7 processes that use directory services. So that directory services DLL is going to be there in memory, okay, as long as any of those guys are running. But it's not, it doesn't get put in each one. Each one has a reference to that memory map page.
Because when I was doing the OD loading and unloading by managing app domain, which
That was in SMA, yeah.
Yeah. Oh, I'm sorry. Which gave me the implication that
No,
library-
even in SMA, we were loading it, but it's getting loaded into a separate page. And if it already was in memory on some page, it wouldn't get loaded again, even though I asked to load it. But it's just like, when you call create mutex. Mutex is a system, if you create a named mutex, mutex is a system-wide resource, okay? It resides down in the kernel. And so the first process that creates that named mutex, the mutex is actually created down in a little bit of memory down in the kernel is created to manage that mutex. And the next process that says create mutex on the same name just gets a reference to that first existing. And this works the same way. Same model. It's a nice model. System-wide named resources. Shared libraries in Linux are going to work exactly. They have to work that way. Okay. I don't know an awful lot about the structure of Linux, but it has to work that way. Okay. So where are we? So it's 4:37. So, so what I'm going to do, there was two things I was going to talk about, and I'm only going to talk about one. I'm going to talk about this COM versus .NET versus native C++. So this is a memory model thing, not a code detail thing. This is just trying to set the memory, your mental model. This roadmap to COM is another one, but I want to give you a little bit of time to either ask me questions about the final project or negotiate among yourselves about the final project if you're looking for a partner. Okay, so we'll do that. So I will just do this one and then I will stop. So let's pull up, I'm going to pull up the PowerPoint presentation. Just because it's a little easier for me to. So a little bit of history. So COM started out by people wanting to embed Excel sheets in Windows. And they could be embedded or they could be linked. The idea of linking was that anytime somebody changes the data in that spreadsheet, it'll change in my document. I have a link to another process. If I embed it, if somebody else changes that spreadsheet, it doesn't affect me at all because I'm not linking to that. No, it's embedded in my application. And that OLE stands for Object Linking and Embedding. And that was the early name for COM. So COM grew out of that desire to have this composite document structure. And then everybody realized how effective that component model would be for building the OS, and they started, and the name fairly quickly morphed into COM. So from object linking and embedding, it became COM. And so now, .NET was supposed to be the next version of COM. So there's the COM we're going to talk about, and then there's COM++, which is really simply some enterprise stuff added to the original COM model. By enterprise, I mean distributed transaction management, mostly COM++ is distributed transaction management or distributed database. And then the next version of COM, when they started working on .NET, it was just supposed to be COM 2 or whatever. But they decided to use this managed model, and they liked it more and more and more, and they said, "Oh, this is better. This is better." So it got divorced from COM. And I don't know whether you remember, but years ago, when Microsoft was working on the version of Windows that was codenamed Longhorn, they projected, here's when it'll be complete, here's when it'll be complete. All of a sudden, it jumped a year. You know, they were saying, we're projecting, we'll deliver at this date, and then all of a sudden, a year later. What happened was, they were trying to replace an awful lot of COM in Windows with .NET. And it failed. It tanked big time. Not that there's anything wrong with the .NET model, it's just that it's a reference model. It's not direct, you know, it isn't the C, C++ native code direct access to. And so that indirect references made a lot of things much more complicated. And so they just took all that code, threw it away, or whatever they did, and then went back in and built, you know, the OS with traditional COM, and they're still doing that. Windows 10 is built largely out of traditional COM. But .NET went its own way, and you know, and became this framework that we all know and have a love-hate relationship with. In my case, okay. I'm like, you know, C# is fine. I like the .NET framework libraries real well. I think they're great. I've stolen their designs in several cases. I've re-implemented the standard system.io as my file system. The file system we're going to look at on Tuesday is just my version in C++ of the .NET system.io. It's got a path class, a directory class, a file info class, a file class, all the stuff that COM has. And its functionality is about the same, works the same way, because it was a good design. A lot of good stuff happened in COM, in .NET, but didn't work for COM. It didn't work for Windows because it was too indirect. So COM strengths everywhere in Windows, nowhere else, not in Linux. Again, I mentioned last time that there was a company in Connecticut that was porting COM to Linux, but they got into a patent battle with Microsoft and a lot of hard feelings got generated, I think. That work was abandoned. So COM strength is it's everywhere in Windows. So it's in the Windows operating system, it's in GUI controls, it's in Word, Excel, Visio. The .NET CLR is a COM object, you know. So there's work going on. I don't know whether you remember from my Windows technology, but I had a WinRT thing. They're still working on that. It was partly for building Windows apps, but not just. Their model really is that we want to do what we couldn't do. We want to build in .NET-ish type stuff into Windows that we weren't able to do. And the way they're doing it is Windows RT are just wrappers around COM objects. But it makes it a little easier to use the COM objects. And that's going to be, I'll talk quite a bit about that as we talk through COM. It turns out that C++ clients for COM are kind of convoluted, and you got to understand a fair amount. But a C# client does almost nothing to talk to a COM object. And the reason for that is originally, when COM first came out, everybody complained how hard it was to build C++ clients for it, or C clients, or whatever. And you can build C clients for it. And the response was to use Visual Basic, to make Visual Basic interoperate in a very simple way with COM. And I'm going to talk about that, but not today. The particular interface, Visual Basic at the time was a scripted language. It wasn't a compiled language. So you can't compile against an interface. And it turns out there's one generic interface called the automation interface that was designed for Visual Basic to talk to. So if I want to call any one of these functions, I call one function, invoke, but I send it a bunch of parameters that tells it, here's the function that I want you to invoke, and here's the parameters that I want you to use for that function, blah, 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 blah. Okay. And that's a mess to set up with C++. I'm going to show you quickly. We're not going to look at it in great detail, because I break out in hives every time I look at it. Okay. But Visual Basic just hit all that, and very simple, almost nothing. And now when Anders Heilsberg was starting to create C#, he said, I want all those VB developers. And half the VB development team came into the C# design team, and now C# uses that automation interface and makes it really simple. It's not fast. The automation interface is slow. Not horribly, but slower than DirectX, but really easy to use. So we'll discover piece of cake to make a C# client much harder to write a C++ client or C++ code. But WinRT, I started out talking about, so WinRT is trying to make that simplicity of action available, but also use COM at the core, to do all the direct stuff that you have to do in an OS. WinRT is also used to build, Windows apps and stuff, but there are so few Windows, other than laptops and stuff, there's so few Windows mobile devices that nobody's writing apps for them. Just no payoff because there's not enough of them out there. So WinRT was partly to build mobile applications, but also to try to build. I expect eventually there will be an API, a WinRT API for Windows, not just the direct C style interface that's I was going to give you some time, but I guess you'll have to talk a little bit after class. So COM is everywhere, accessible for clients built with different languages, C, C++, C#, VB, JavaScript. All these guys can talk to COM. Python can talk to COM objects. All the scripted languages talk, and C#, which isn't scripted, talk to COM through the automation interface. Because they can't compile against an interface. You know, COM is, to its core, it's an interface thingy, but C# and the scripts talk to an interface, a generic, universal, automate that one interface that never changes. And so the scripting language has built in the structure to talk to that one interface, even though you can't compile to talk to, you know, some custom interface we developed. So that's how that works. But anyway, one of the things that makes COM more complicated is that they want to support a whole bunch of languages. They want to support any kind of C++. I don't care what standard compliant compiler you're using. A client written in MetroWorks should be able to call a COM component written in IBM's compiler, whatever that compiler's called. Okay, and it does. It works because they don't allow exceptions to cross COM boundaries. Okay, they just use error codes, and so error codes can be handled across languages without any problem. There's a bunch of things like that. One of the important things is that these different languages have different specifications for the type. An int may have a different size in C# and in C++. It does, actually. And last time I looked, maybe it's the same now. But COM uses a reduced subset. They use there's a specification for networks called the network data something or other, network data specification or something. Yeah, it specifies the binary format of all the data that a network should be able to handle natively. And COM uses that specification. So that means that you can't send just any old thing. You can't send a vector, a C++ vector, through a COM interface unless you tear it all apart, which you can do. You can send the vector contents, but you got to tear it all apart. You got to take the contents of that vector and put it into what's called a safe array, which is one of the COM known data types. And a safe array, COM safe array, I believe is identical to a C# array. And I believe a COM has something called a B string, which is their string representation. And I believe the B stands for basic. And I believe that's exactly what C# uses. Because there's no interoperability problems at all for strings and arrays and stuff like that between COM and C#. It just works like a charm. But with C++, you got to be more careful because now you don't have that same type. But we'll get into that. We'll talk about that.
Professor?
Yeah.
So what you meant to say was that like when we are trying to use codes in two different languages through COM, so we should use types and things present only in the COM?
So what I'm saying is that you'll build a component out of one and only one language. You'll build a client out of one and only one language, but they can be different languages. And for this client to talk to that COM object, you've got to send a very restricted set of types, the network data types, through that interface. So you can send a safe array, you can send a B string, but it gets significantly more twitchy to send a C-style string, an array of characters, because is this Unicode, 16-bit characters, or is it ASCII?
What if I wanted to talk to two different, like client is in one language and the library is in different language, so